Question 3 has a diagram showing a cross-section through a step index optical fibre, and in A part 1 we need to name the parts A and B. Well, A goes around the outside and is the cladding, whereas B is the core. In part 2 we need to complete the path of the ray through the fibre, assuming it undergoes total internal reflection at the boundary between A and B. Well, the ray will go something like this. Points to note: here we have refraction towards the normal. The angle here, the angle of refraction, is slightly smaller than the angle of incidence. At this point we have total internal reflection, and the angle of incidence here is roughly equal to the angle of reflection. This would be judged by eye. The examiner would not use a protractor at this point. In B, we need to calculate the critical angle for the boundary between A and B. We're given the refractive index of A at 1.46 and that of B at 1.48. Well, the sign of the critical angle is N2 over N1, where this is the refractive index of the substance the light would travel into, this the refractive index of the substance the light is leaving. Putting in the values given gives theta at 80.6 degrees. In C, we need to state and explain why part B, the core of the fibre, is made as narrow as possible. Well, having the core as narrow as possible reduces the effect of multipath dispersion. This is because it minimises the path difference of signals travelling at different angles, and therefore reduces pulse spreading, which can limit data transmission rates. In D, we need to state one application of optical fibres and explain how this has benefited society. Well, one application is optical fibres' use in transmitting data. This has benefited society in that it has increased the speed and security of data transmission, leading to the high-speed internet we have today.